Hi, I'm Carolyn. I'm a data scientist by background. I studied applied economics. I've been in data for about 15 years and in data science for over 10. I currently lead the AI ML team at InsurTech Clearcover, a modern digital first auto insurance carrier. Our team is responsible for both traditional machine learning as well as generative AI for the company. We have use cases ranging from customer acquisition through to claims processing. I'm really passionate about building ML AI solutions that have an impact on the business, and I'm excited to be here today to share some of what I've been learning over the last couple of years. So our team at Clearcover has been focusing heavily on GenAI since early 2024. Today, I want to share some of the things that surprised me through this journey, where what's worked for us wasn't really what I expected going in. Before we get into that, I wanted to share some context about what we've built. We have two in-house GenAI applications. One is a customer-facing digital statement collection tool. We call that DISCO for short. And the other is an internal claims adjuster assistant with broad functionality. Our claims adjuster assistant bot, named Terrence Bot, that's him in the top right. He is a rocket turtle, but that is a story for another day. That started very simply as a Slack bot where claims reps could put in a claim number and get back a summary of the claim based on claim notes, emails, SMS history with the claimant. Auto insurance claims can include injuries, and those claims can take months or years to resolve because you have medical and legal complications. So if you have one claims rep leave, so a claim needs to be transferred to another rep, there can be 30 to 50 pages of content that they need to slog through in order to understand that claim and get up to speed. With the claim summarizer, they can greatly reduce the amount of time needed to get up to speed on a claim. But that was just the beginning. We've connected TerranceBot to all of the data that the claims reps typically use to do their jobs. So reps can draft communications to claimants and attorneys using the specific details on the claim. It can also find out how state-specific procedures affect a claim and ask questions about unstructured attachments. I'll show a couple examples in a second. Technically, Terrence is a series of AWS Lambda functions using serverless application model, including an AWS Bedrock agent connected to a variety of tools. Those tools include RAG functionality with a knowledge-based vector store, tools for accessing various data sources from databases, and API calls to claim system or policy administration system, and tools to digest unstructured claim attachments like PDFs, photos, and MP3 call recordings. Other tools we have hooked up also use LLM calls themselves, but with specialized prompts to do things that the generalized agent doesn't do as well. So a couple examples, as promised, of TerranceBot interactions. These are anonymized. So for example, you'll see car model 123, claimant vehicle driver 1. That's just so that we can share this here. Our claims team does see the actual claims details. So left screenshot, we can see a typical claim summary. User asks for a summary of the claim. TerranceBot goes and gets a pile of data about that claim, summarizes key info that the rep would typically care about. What happened, details on any injuries, current status. In this case, we have a claim where the insured vehicle ran into another vehicle, so our insured is 100% liable, and their vehicle is a total loss. The person in the other car is making a claim. They have a back injury that they've sought treatment for. And this particular claim is almost ready to close out. There were negotiations, settled, payments been made. Right screenshot, when our insured file a claim, they upload photos of the damage. Those photos are automatically attached to the claim in our claim system. So here the user is asking, based on the photos attached, is this vehicle a total loss, meaning is it totaled? So TerranceBot can take a look at what's in those photos and make conclusions. Here, the rep is asking for input on is it totaled. TerranceBot can see the damages to the rear corner of the vehicle and specifies which vehicle parts. It can advise that there will likely need to be significant body work, but by considering the damage in the photos and looking at the estimates data on the claim, TerraSpot can conclude the damage is very unlikely to have totaled this vehicle. So that's an example where TerraSpot is looking across multiple data sources and data formats to make a comprehensive answer. Another example where we see this happen is we use a third-party report that we order that tells us about claimants' past claims with other insurance carriers. Reps can ask TerraSpot to look at the photos on the claim and compare them to the claims in that report to see if the damage visible in photos is consistent with any historical claims, which could indicate potential fraud. Our other in-house GenAI use case is customer-facing. Traditionally with car insurance, if you file a claim, you would submit a form and then a claims rep would maybe leave you a voicemail asking for time to talk. You might play phone tag a bit, and then you have to do a long phone call with the rep where they're going to take a bunch of answers to questions. They're going to record this statement. So we wanted to make that experience faster and easier for the customer, and meanwhile reduce claim adjustment labor costs. We didn't want to just make a giant web form, because then you'd have a super long, not very fun form. Users might have to repeat information that they already said when entering their narrative in the claim form or when answering an earlier question. So we set this up as an LLM-based system. One LLM identifies what information remains that we need to know for the claim. So let's say we ask you if you were injured and you say, yes, and I went to the urgent care and they said that I sprained my wrist. So now you've answered 3 questions. You were injured, you sought treatment, and what the injury is. So we can drop 2 questions from what you need to answer. Meanwhile, another LLM crafts the message to fit in a conversational flow based on the conversation history to that point in time. And then a third acts as a safety check. For example, we want to exit the conversation if someone mentions a fatality because we want that to be handled by a human. I have a short demo here to give you just a little bit of flavor about Disco. This is made for our agents, so let's just pretend that we sell insurance.
At Clearcover, we're an award-winning car insurance company, redefining the claims experience with smarter technology and seamless service, helping you, the agent, build lasting client relationships with ease. Meet Disco, the digital statement collection bot, our AI-powered solution that's revolutionizing first notice of loss, ensuring your clients get the fastest, most efficient claims experience possible. Disco streamlines recorded statements, reducing the time customers spend with adjusters by intelligently selecting from over 90 possible questions based on their responses, so claims move faster and with fewer roadblocks. Over 60% of customers choose Disco, and those who do receive their first payment nearly 20% faster. Faster claims mean happier clients, and happier clients mean stronger retention and more referrals for you. By automating statements and follow-ups, Disco eliminates scheduling hassles and ensures accuracy, so your clients get smooth, stress-free claims while you focus on growing your book of business. With Disco handling the claims process efficiently, you get more time back in your day to do what you do best: sell, support, and scale your business. Faster, smarter, easier. That's Disco, helping you deliver exceptional service while growing your business.
Okay, so that's Disco. So that's a couple use cases of what we have done with GenAI, but
At Clearcover, we're an award.
mostly today, I want to talk about some of the things that have surprised me along the way technically while we're building those things. Going in, I'd heard a lot of talk about vector searches, fine-tuning models. At the time, there was a lot of talk about self-hosting models because of security concerns around models as a service. And what we found worked for us was a bit different. When we started this, all the talk was RAG for everything, vector search for everything. We do use a vector store for knowledge-based content pulled from Confluence for TerraSpot, but most of the data we use is pulled by more specific queries via tools. So in our use case, the users want to interact about a specific thing. For us, that specific thing is a claim. For you, you might have use cases where it's a customer account, something else like that. So rather than asking general knowledge questions, if we were to just do straight semantic search on all of their questions across all of our claims data, we would get a lot of irrelevant information because what we really care about is this specific claim. So instead, we have tools do things like pull a claim's notes, emails, SMS, look up its policy information, or look up details about people on the claim. Depending on what we're doing, that might be injected into a prompt, or it might be the response of a tool that gets consumed by the central agent. We also found when users had questions about unstructured claim attachments, we needed to set up ongoing processes to create LLM-generated metadata rather than relying on chunking up documents and looking for similarity at time of the question or searching claims notes. We used a few approaches here. One is ongoing capture of specific numbers from claim notes and emails. There are a lot of dollar amounts mentioned on a claim, so an LLM can get confused if you ask it what an attorney's settlement demands were or what the most recent offers on that were. So we check each incoming note or email to see if there are demand or offer amounts and capture that. Then we have a tool that looks up that structured data when it's relevant to the agent. Another tactic we've used is to make page-level classifications of attachments on the claim using a fine-tuned foundation model so that the agent can look up exactly what data to pull when. That both improves latency of the response and saves on tokens. The last metadata tactic we've used was to construct brief summaries of each attachment as it comes in. Very similar purpose. We then provide that information to the agent as additional context to know what content to pull in for a particular query. Fine tuning. Here's when we're going in. I was sure we would need to do this. I thought we would need to host an open source model. That's GPU intensive, so we would need to shrink it as much as possible. So we would want to fine tune a smaller model, maybe do quantization. We'll talk about hosting in a second, but first fine tuning. And by the way, even today, periodically, I still think, hey, we're probably going to need to fine tune for fill in the blank thing. And then I am surprised that I don't need to. So a small example, a couple months ago, our legal and compliance team stays on top of legislation that could affect our company. And there is a shocking amount of legislation that gets considered or passed. Insurance is regulated at the state level, so we have to look across a bunch of different states. So they had about 7,000 pieces of recent legislation across a bunch of states where they needed to identify if it could affect our business. They'd gotten through about 700, so we had a nice labeled data set. I thought, this is a pretty specific use case. We may need fine tuning. And I thought the examples they'd already reviewed were going to be great for that. Then I worked with the legal and compliance team to understand exactly what makes a piece of legislation relevant or not. Played around with some few shot examples and some prompt tweaks hitting Claude Sonnet 3.7. We used some of those already labeled sample pieces for validation. And after a few iterations, we found we were already where we needed to be. We had the LLM classify each piece of legislation into 3 buckets, yes, no, or maybe relevant, and had it provide brief reasons and erred towards yes or maybe over no, so that any questionable cases could get human review. Meanwhile, we could knock out the majority of pieces of legislation so that they don't take up valuable review time. And because we were able to just use one of the frontier models with some prompt engineering, we were able to knock this out in a morning. We didn't have to do anything particularly special. I'm sure there are a lot of more nuanced frameworks out there for deciding whether to fine tune. This is what's worked for us. The frontier models like Sonnet 3.7 or GPT 4.0, they aren't expensive until you get really, really big volumes. So a lot of times we can just run with some prompt engineering and making sure we're passing the right context. So first we do a quick check. What would that cost for this particular use case? How many times are we going to hit it? How many tokens do we think we're going to hit it with when we do that? Is that cost acceptable? Let's say the cost is okay. Now let's do some initial exploration. does prompt engineering and providing that right context to a pre-baked model get us where we need to be in terms of the quality of the response? If so, great. If not, maybe we think about fine-tuning. Almost all of our GenAI use cases have not required fine-tuning. One exception is I'd mentioned we have a fine-tuned foundation model to classify PDF attachments on a claim. That is really niche content. One thing not represented here, there are, of course, smaller versions of these frontier models that can be a good in-between option. If Sonnet is too expensive, but the problem is relatively simple, maybe Haiku will do. That's always worth checking too. Okay, as promised, hosting. We were initially really skittish about hitting any model that wasn't hosted specifically within our AWS environment. We did our initial prototyping using Flan UL2, which probably dates when we started this because it was before the first Llama model came out. And then two things happened. One, we did the math on what that was going to cost. It's GPU intensive, and we would want redundancy. And our volumes aren't huge. We get hundreds of claims per week, not hundreds of thousands. So hitting a pay-per-token service is just a fraction of the cost for us. Second, the big cloud providers got on top of supporting enterprise use of these kinds of services. So we were able to go through Azure OpenAI and AWS Bedrock and leverage their authentication and other features. If we'd self-hosted, it would also be more work for us to upgrade the model we're using. Instead, since we're paying per token, our code is generalized. We can just swap out a model identifier and run. This one's even simpler than the last one. For us, the big LLM API providers, now that they have more robust enterprise functionality, it to us comes down to the volume of traffic for whether we're going to host. So we get, I mentioned, hundreds of claims, not hundreds of thousands of claims per week. For these use cases, we just don't have the volume for it to be worth self-hosting a model. It's more cost-effective for us to pay per token. Last set of technical learnings I wanted to share, how we call these LLMs, which sounds simple, but there are a few things we found that helped us keep this running smoothly. First, these models get replaced super quickly, so we need to keep our code model agnostic. We've built OpenAI style and Anthropic style abstraction layers. So when we need to change to a new model, we can simply swap in that new model identifier, and then we store prompts separately from the LLM calls. Error handling and fallbacks, obviously that's not anything new to engineers, but we have seen that these LLM APIs have had some really iffy reliability and sometimes throw HTTP error codes that don't seem to make any sense for what's actually happening. So that means we need to be robust to errors with backoff and retries and potentially fallback models in case a model service is down entirely. Last thing here, recursive response updaters. In some cases, we've had content that is too big to return from a tool to an agent. In these cases, we've set up loops to gather intermediate information and combine all that information into a condensed output from the tool to the agent. That's been especially helpful for us when dealing with extremely large PDF attachments that can be thousands of pages. A lot of what we built before agentic frameworks were where they are now. LangChain was a thing when we got started, but wasn't production ready. We're currently migrating some of our stuff to Pydantic AI. We already use Pydantic for a lot of our stuff. So some of what I mentioned on the last slide is natively handled by these frameworks. They give abstraction. Pydantic in particular gives type safety and response validation, and there's error handling and retries baked in. That doesn't solve everything though. We still need to hook up any data we need to use, design use case specific prompts, put any industry or use case specific guardrails like our fatality check and Disco. And there may be other things that are going to make it work better for you, like our extraction of structured content out of unstructured that we then call that as a tool. My asterisks here in the bottom right, MCPs are a hot thing, but they don't remove the need to do custom integrations to our internal systems. This one is not technical, but I did want to call this out as a key part of our GenAI journey. Clearcover takes a thoughtful, transparent approach to AI. We recognize the importance of aligning this with both insurance regulations and customer expectations. So we're working to prioritize fairness, transparency, responsible design while partnering closely with our legal and compliance team. We do have strong internal and external oversight in place. We have an AI governance committee that meets regularly to ensure clarity and accountability in how we apply AI. We maintain open communication with regulators to make sure that we are using consistent, thoughtful implementation of AI. And we've also helped launch the InsurTech Coalition to support responsible innovation in our industry. As a founding and active member, Clearcover is proud to collaborate with other forward-thinking companies through the InsurTech Coalition. It's a nonprofit focused on promoting responsible AI practices, supporting thoughtful regulation, and advancing shared industry goals. That's briefly a few of my learnings from the last couple of years getting into GenAI. I had some expectations, whether they were right or wrong, going in about what would happen. And what we found useful has been a little bit different than I expected. On the technical side, we've been really pleasantly surprised at how far we can get with simple solutions without overcomplicating. We've leaned on direct data retrieval over vector search for most of our use cases because our users typically want to talk about a specific thing. For us, that's a claim, while still using a wider semantic search where it makes sense. I thought we would need to fine-tune models because insurance use cases are often quite niche, but I've been shocked at how far we can get just with prompt engineering and providing the right context so that we can get solutions faster using frontier models. I also thought we would need to self-host models, both because the big vendors weren't supporting fine-tuning at the time, and because there wasn't enterprise support yet for security and authentication in using models as a service. But our claims aren't insane high volume, so self-hosting would have been pretty expensive for us, and we can lean on solutions like AWS Bedrock and Azure OpenAI instead. We've also worked hard to keep our code model agnostic so we can easily swap in new models. We've switched back and forth between OpenAI and Anthropic models based on service latency and availability, and we've upgraded to newer versions of models several times. Because we've kept our code agnostic, that makes that a quick change. We do some testing in a lower environment, and then we can go. We also have some takeaways on the organizational non-technical side. We've been able to try a lot of things with our internal facing app, TerranSpot, and work out kinks in a way that we wouldn't be comfortable doing in our customer facing application. We would have to take a much slower, more measured approach in making any changes to a customer facing application. So that's helped us learn and build faster. I strongly believe our GenAI apps have been successful because they're solving real business problems in a way that it would be hard to do as well without GenAI, rather than starting from a place of what can we AIify. As with any ML AI effort, cross-functional collaboration is key with business areas that will be using the app or its output, as well as any internal engineering teams that might hook up to our work, and legal and compliance to make sure that we're thinking about the right things and taking the right approaches in a heavily regulated industry where regulators' understanding of AI is evolving. Another thing, and I think this is true for engineering efforts broadly, providing incremental value, receiving feedback, and iterating can create much better adoption than squirreling away to build the ultimate application and lobbing it over the fence at the end. We've been able to benefit from the incremental approach a lot with our internal claims adjuster assistant. Lastly, pragmatism wins, solving business problems with the right tools without over-engineering. So that's what I had to share with you. Thank you so much for your time today. If you'd like to connect, please feel free to reach out on LinkedIn. And I hope you enjoy the rest of the conference.